All right, let's take a look at a few of these problems here. Now the first few are not too difficult. Remember, we're only going to stick with working on one side or the other at a time. So number one, you got your formula secant squared minus 1. So let's check out the formula sheet and see about secant squared minus 1. Let me make my view, hang on a second, page, there we go. Secant squared minus 1. All right, so secant squared minus 1 could be tangent squared. Let's see if that helps us out. Okay, let's do that. Because we could also just multiply this out, like we could distribute as well. That's another step you could do. So, step 1, I'm going to change secant squared minus 1 to tangent squared. You can write theta or x, whatever is more comfortable, and then you get cosine squared equals sine squared still. All right, so this right here, tangent squared, remember tangent is sine over cosine, so that's sine squared over cosine squared times cosine squared still. And there we have it. Cosine squareds cancel. We got sine squared equals, and I'm just going to check that off because we did it. All right, number 3. For number 3, I got sine minus sine times cosine. I think right here I'm going to factor out a sine. So if I factor out a sine, that would leave me with a 1 right here, and then minus cosine squared. All right, I recognize that. This is supposed to equal to sine to the third. All right, 1 minus cosine squared. Well, whoopsie, wrong way. 1 minus cosine squared would be sine squared. So this right here is going to change to sine squared. So sine times sine squared. There we have it, sine to the third. And yes. All right, so number 6. So number 6, again, with some factoring. On number 6, I noticed they both have a tangent. So let's pull out a tangent. And that would leave me with a cosecant squared minus 1 equals, and number 6, let's see, cotangent. So I don't want to change that. Now in this case, everything that's been easier has been on the right side, so I've been working on the left side, but it could be the other way around. I mean, it doesn't really matter which side you start off first, but a lot of times they put the side on the left that is going to be the side that you're going to work on. All right, so cosecant squared minus 1, let's check that out. Let's see, cosecant squared minus 1 would be cotangent squared. So, tangent theta times cotangent squared. Now remember, when a cotangent is next to a tangent, they cancel out. But I have cotangent twice here, so really I have this, tangent theta times, I have cotangent times cotangent. So if we separate it out like that, then this and this can cancel because cotangent is 1 over tangent, so they cancel, and then we get cotangent, exactly what we wanted. All right, so let's check out number 7. All right, number 7. All right, so we got secant theta over sine theta minus sine theta over cosine theta equals cotangent. So this is a good candidate for getting a common denominator, okay? So my common denominator would be sine and cosine together. So I'm going to put those together. All right, so that means I have to multiply cosine times this. Well, cosine times secant, I'll write it down, but I hope you already know that that's going to turn into a 1. And then sine times sine is sine squared. All right, so secant and cosine are the reciprocal of each other, so they turn into 1. I get 1 minus sine squared over sine times cosine. All right, 1 minus sine squared, that's a Pythagorean identity. 1 minus sine squared is cosine squared. Oopsie. So I have cosine squared on top over sine and cosine. All right, so just some simple algebra. One of these cosines cancels with one of those, so I have cosine over sine left. Well, cosine over sine is cotangent. All right, and so as you start to do these more, you get more familiar with things and you start to see them and you're like, oh, I see, it's coming. All right, so number 8. So number 8, looking at that, that's another candidate for like a good common denominator. So I'm going to have this item and this item in my denominator. So I'm going to be multiplying sine times this. So I'm going to be multiplying 1 minus cosine times 1 minus cosine. All right, so it's going to take a little bit of space. So I'm going to start off on number 8 with my common denominator. My common denominator is my 1 minus cosine times my sine. All right, so that means I have to multiply sine times that guy. So that would be sine squared. Plus in the middle. Then I have to multiply 1 minus cosine times 1 minus cosine. So I'm going to write that out. And 1 minus cosine. All right, this is all supposed to equal 2 cosecant. All right, so this guy right here, let's do that. 1 times 1 is 1. 1 times minus cosine is minus cosine. Minus cosine times 1 is minus cosine. We're just foiling. And minus cosine times minus cosine is plus cosine squared. All right, so I can clean that up when I write it. I got sine squared still. I have all of this. So plus 1. Cosine and cosine, that's minus 2 cosine. And I have plus cosine squared. All over. Now this doesn't really help me to multiply this out yet, so I'm just going to leave it not multiplied. Just for now. All right, so let's take a look. Cosine squared plus sine squared. Remember, cosine squared plus sine squared equals 1. So I'm going to replace it. So this guy and this guy are replacing with 1. And I have another one right there. There's going to be 1 plus 1 is 2. So I have 2 minus 2 cosine theta over 1 minus cosine and sine. And you want to recognize some of these things in your head a little bit because you don't want to sit here and like write it all these things over and over. It takes forever. All right, so let's look at the bottom right here. 1 minus cosine. I got 2 minus 2 cosine. I can factor out a 2 from here. So if I factor out a 2, that leaves me with 1 minus cosine. We're almost done. So I got 1 minus cosine times sine. All right, cancel, cancel. So 2 over sine. Well, if I bring a sine up to the top, it's cosecant, exactly like I want up here. So that would be 2 times cosecant. So if you get to that point, you can just assume that we both know that you'd have 2 over sine and it turns into 2 cosecant. All right, let's see, number 12. 12, good candidate for common denominator again. So on number 12, I'm going to basically bring this up top, like multiply 1 by cosecant minus 1 and multiply positive 1 by cosecant plus 1. So it's a little bit like cross multiplying. So we get on the denominator, we get cosecant plus 1 and cosecant minus 1. On the top of the left, we get cosecant minus 1 because 1 times that. And let me check and make sure. In between here is a plus sign, so I'm just going to I want to make sure it wasn't a minus, so plus. And plus doesn't change anything. I just get cosecant plus 1 because remember we're multiplying this by 1. All right, so when I look up there, oh nice, the 1's cancel, and I got 2 cosecants. Now, you notice in the last problem I did not multiply the denominators together because I think it was like cosine times sine minus 1 or something, or no, it was cosine minus 1 times sine. And that wasn't going to like do anything for me, so I kind of just left it. In this one though, give me a second. In this one I noticed these are conjugates. So when I multiply those together, cosecant squared, I get cosecant squared minus 1, right? Cosecant times cosecant is cosecant squared. I'm going to get minus cosecant plus cosecants, those go away, and then minus 1. And that's probably replaceable. Cosecant squared minus 1, let's see, there it is. Cosecant squared minus 1 is cotangent squared. So we get 2 cosecant over cotangent. All right, so at this point, I got too much going on with like my inverse identities and whatnot. Let's change everything to sines and cosines because I would recognize what to do with those better. So cosecant is 1 over sine. So this is going to be 2 over sine theta. That's my top. Bottom is cotangent squared. Remember, cotangent is cosine over sine. So we're going to change that into cosine squared over sine squared. All right, I'm going to flip that bottom guy up. So I get 2 times sine times sine squared over cosine squared. All right, let's check out what we want right here. All right, 2 secant times sine. 2 secant squared. I got my 2. Secant squared. So secant squared is 1 over cosine squared. I have that. Did I write this wrong? Number 12? Secant squared times sine. Look at it, sine squared. Hang on. Cosecant squared minus 1 is cotangent squared. All right, let's take a look. Make sure I did everything right. Cosecant over sine. Okay. 2 secant squared. That should be sine to the third, I'm thinking. Let me pause and go see if there's a typo. All right, there was no typo, but I made a mistake. Oh no. So did you notice that right here, when I had 2 sine, then I wrote 2 over sine, I wrote 2 times sine. That was a mistake. And so that happens sometimes, and things weren't working out, so I went back and checked my work, and I saw that I did that. So let me change this. All right. So sometimes, happens to the best of us. So I got 2 over sine theta, right? Now it's going to work out for me. All right. So that means that this sine and one of these sines cancels. So on the top, I have 2 times sine. On the bottom, I have cosine squared. I could just leave it like that, but I do notice that this wants a secant squared. So, and I got my 2 and my sine, so secant squared. If you bring that cosine squared up, remember 1 over cosine squared would be secant squared. So 2 sine secant squared. And we got it. All right. So that's good. You see everybody messes up sometimes. It's okay if they're in a different order like that. It's fine. All right, so let's see. That was number 12. Let's see, 20. So number 20. I think the most obvious thing to do on number 20 is to FOIL this out. All right, so that's what I'm going to start to do for number 20. All right, so I got cosecant times 1, so that's cosecant. Cosecant times cosine, negative. Cosecant times cosine. Then the inside plus cotangent. And then here, cotangent times cosine minus. All right, now that I did that, and it's all equal to sine, I'm going to change everything to sines and cosines, or at least these pieces right here. Let's see what happens with these. All right, so I got cosecant minus, cosecant is 1 over sine. All right, let's see, times cosine. That doesn't really help me that much. I got plus cotangent minus this guy right here. Cotangent is cosine over sine, and then I have times cosine. All right, let's check this out. Okay, so I think I'm going to go back and change this one as well. That's 1 over sine, and this one also. I didn't change those because I didn't think I needed to, but let's do it. So it's 1 over sine. And this guy right here, cosine, what was this, cotangent, is cosine over sine. Ah, now I see, look, they all have a sine on the bottom. So let's take a look. So they already all have a common denominator of sine. And then we just combine the tops. I got 1 minus 1 times cosine is cosine, plus cosine, minus cosine squared. There we go. That was tricky. All right, so cosines cancel. Remember, last thing you can do, like change everything to sines and cosines if you get confused on something, and that's what I did. All right, so on the top I have 1 minus cosine squared. The bottom, sine. All right, 1 minus cosine squared. Hopefully you recognize that enough now. 1 minus cosine squared is equal to sine squared. over sine. And there we go. Those cancel out. One here, one there. I get sine. All right. So 23. 23. Let's see. I can split this fraction. Let me try splitting these fractions into two, because I would get 1 over secant, which is cosine. Then I get cosecant over secant, which I'd have to work, figure out, but it might be cotangent. And it will be. All right, so I'm going to split this into two fractions. 1 over secant. Remember, we're allowed to do that when the addition or subtraction is on top. And then cosecant over secant. I want this to equal cosine plus cotangent. All right, so 1 over secant, I already got my cosine. All right, remember, that's just one of the rules. 1 over secant is cosine. All right, oops, not an equal sign. All right, so plus, let's change everything to sines and cosines here. 1 over cosecant on top is 1 over sine. On the bottom, secant is 1 over cosine. All right, there we go. So this part over here, the 1 over sine stays. The 1 over cosine flips up, cosine over 1. And so there we go, cosine over sine, there's my cotangent. So sometimes when I'm working on something, I leave the other part, and I'll just fill it in later. All right, and we're done. All right, and 25. So number 25, there might be some Pythagorean identity things going on here. So let's look up the 1 and the tangent squared. So let's see. Whoopsie, wrong way. So tangent squared plus 1 is secant squared. So let's check out what we can do. So I can change the top to a secant squared. So I don't really know if I like that because it's not really going to help me out. So I think I might like to change everything to sines and cosines here, because if I change the top to secant squared, it's not like I could separate the fraction like I did in this last one. So let's change everything to sines and cosines and see what happens. So what is this, number 25? All right, so I got on top, I got 1 plus tangent squared is sine squared over cosine squared. And the bottom, I have 1 minus, I got sine squared over cosine squared. All right, so I think let's get some common denominators. On the top, I would have cosine squared as a common denominator, which means my fraction on the top, this guy, the sine squared would stay the same, but the cosine squared would multiply by 1, so I get cosine squared plus sine squared. I like that because cosine squared plus sine squared is equal to 1. All right, down below, I get cosine squared, and I basically have to multiply cosine squared times 1, so that's cosine squared minus sine squared, that stays the same. All right, and what are we trying to get this equal to? 25, I have 1 over 2 cosine squared minus 1, and we'll just see if this works. All right, so notice here, if I were to rewrite this, I'm going to change this to a 1, so 1 over cosine squared times, and this bottom fraction is going to flip up, so it's going to be cosine squared over cosine squared minus sine squared. All right, there's a cancellation, and we're almost done. So it's 1 over cosine squared minus sine squared. All right, so let's see. This guy has all cosines, so I'm going to change this sine squared. Remember, sine squared can be changed to 1 minus cosine squared. So let's do that. So I have 1 over cosine squared minus sine squared can be changed to 1 minus cosine squared. All right, I think we've got it. When I apply that negative right there, I get this part right here, I get cosine squared minus 1 plus cosine squared, right? Because minus minus makes a plus. So I have 2 cosine squareds minus 1. So there we go. 2 cosine squareds minus 1. And we found it. That's exactly what we wanted, right? Yeah, there we go. Alrighty, last one, 26. So number 26, all right, it's not looking too bad here. This is kind of an easy one, even though it's the last problem. All right, number 26. I know that tangent is sine over cosine, and I know they're going to cancel right there. So let's check it out. Tangent would be sine squared over cosine squared, tangent squared that is, and then times cosine squared. All right, cosines cancel. I got sine squared equals 1 minus cosine squared. And I know that to be true, but I still have to write it. So I have to change sine squared. I have to change it to 1 minus cosine squared. Because remember, sine squared is 1 minus cosine squared. All right, so 1 minus cosine squared is sine squared. All right, and so then we're done. Whew, glad that was an easy one. All right, see you in class. Bye-bye.